All right, 1.3 exponential functions. Okay. Graph the function, state its domain and range. Something wrong?
I don't think so.
Okay, I'm just checking.
I thought you were talking to him.
Well,
maybe some of our answers.
Something's wrong over there. I don't know.
Maybe it'll be some of our answers in the near future.
I felt like y'all were giving me the I don't want to do this look.
That's what I thought Josh was doing. So I was looking up at him. I was like.
Okay, anyways.
Positives and whatnot, and then
We are going to graph this and discuss the domain and range.
that's the wrong number.
Maybe I don't want to do this. I forgot how.
Graphs.
Well, what does the graph of a base exponential function look like?
Okay, so I'm gonna do it backwards for you so that it looks like what it's supposed to look like. So it goes like,
Okay.
Yeah.
Where does it intersect the y-axis?
0.
I'm gonna say,
Oh, this one in particular?
I'm gonna say 3.
No, in general.
Oh, 1.
1. So which way is this going? Up 3.
Oh.
So this one is going to be at 1, 2, 3 up here. It's at 4, but I went up 3 from 1.
That makes sense. 'Cause they just normally start out at 1, so then you. So
She's
1
like,
is
wee!
1 is your origin then, right?
Basically, yeah.
We all have to start somewhere.
Because e to the 0 is 1, so. And it shifted up 3, so we can just, wee. I feel like in the middle of a quiz or something, y'all are going to be like, wee!
I drew mine too close to the title, so mine doesn't look very good.
Okay.
So it's like, whoop.
What?
Instead of wee, hers is wee. Like wheatens.
No, I did not.
All right, what's the domain of this graph?
All real numbers.
All real numbers. What about the range?
Ooh, I got this, Josh. Don't say it. Let me
You're
think.
taking too long. I'm
No,
about
let
to
me
say
think.
it.
Oh, it's 4 to infinity.
No.
It's not?
3 not included to infinity.
3 not included to infinity.
Okay.
Because if we had a normal exponential graph, it would never touch 0, but it cuts through 1, so it gets close to 0. So we've got to go 1 below wherever the intersecting point is. So since this one intersects at 4, I have kind of like an asymptote here.
Okay. Is that only with exponential that we do that, or go?
Well, exponential, we can't have I don't want to say we can't have negative exponents because you hypothetically could, but for the sake of this, it doesn't. Basically, whatever your intersecting point is, go 1 below it.
Okay.
But you also have to think if this was a graph that was shifted right or left, then it's going to be a little different. But if you keep plugging in numbers like negative 500, it's going to just be really close to 3.
Yeah.
Which is why it's like that, so.
If we had gotten a cookie point, if we had pointed out that.
No, I would not have given you one for that. That's not worth a cookie point. Also, my infinity looks bad. Okay, there we go. It doesn't really look any better, but I tried.
Well, I don't remember what the other one looked like, so.
Never mind. I was gonna undo it and redo it, and it's too much work. Okay. Rewrite the exponential expression to have the indicated base. So, 16 to the 3x base 2. So how can I rewrite this so that it's a base of 2 instead of 16?
You do 2 to the. Okay, hold on. Let me think.
2 to the 4.
Yes.
So what is that?
2 to the 12x. Can I multiply those?
Yep.
2 to the 12x.
Nice and easy.
Yay.
Because it's technically, in case you need to see it, this was technically 2 to the 4th raised to the 3x, which is why it's multiplied.
Can our entire AP exam be like just this stuff? Minus the graphing. Then we'd all get 5s.
I was gonna say, I don't know about that one, Chief.
Virginia, you're not stupid.
I don't know about that one.
See, it's even on video that you're not stupid.
All right, so 1 over 27 raised to the x in base 3.
Well, 1 over 27 is like 3 to the negative 3.
Yep, so we need to have that negative exponent. So this is going to be 3 to the negative 3. Oops, wrong color. Hold, please. Bless you. Squared.
Math stuff.
That's what Kenny says. Then he'll be like, cubed. Yeah. Okay, 3 to the negative 3 to the x would be 3 to the negative 3x. It's like, because he's a third, we call him, like, well, I say we, my mom and I call him K cubed.
Cute. I love that.
And his dad is K2.
Is his? Oh yeah. That's like what my cousins do too. Their name are all James.
There's 7 Kennys in the family.
7? Is he the 7th one?
No,
Or-
he's the 3rd one.
Oh.
But I mean in the whole family.
Yeah.
Because his dad, his grandpa, which he's passed, but his grandpa, and then his dad's 2 sisters both married Kennys, and both had a son, Kenny.
So many kitties. Are you gonna have a kitty?
I hope so.
That would be. What would you be?
Like what?
K4.
Like what? Would that be like keeping the family tradition or something?
Yeah.
Yeah. Keep it alive.
I'm not going to be the one to break it.
You should name it like something slightly off from Kenny, just so it's like, what would it be? A name is close to that. What
Kenny?
like Kent?
I don't know. I say candy.
Yeah, you know.
Carrie.
Oof.
Oof. I don't like this kind of math.
Find the zeros up the function.
Oof.
See,
Let me get
you
my
did.
calculator.
See, you did it too.
I don't like this one.
F of x equals e to the x minus 4.
Oh. Okay, that's not so oof.
Are you sure?
No, but that's not so oof. I mean, what? There's only gonna be 1 0.
Correct. There will only be one.
So that's why it's less oof. So are we allowed to do calculator on this one? Oh, okay, cool. That's nice.
This one doesn't have a gray background, so you can.
Oh,
In the book.
Yeah.
For
I saw that last night when I
Zoom
was
and
in
whatnot.
Zoom in whatnot.
Okay, we do the thingy, we do the zero finder.
Wait, does it
Find my zero.
does it go to
Found
the left
it.
of the Y or the
I found
Y
it.
axis?
It's like left if you're following the graph.
Okay.
And it's of the x.
Okay.
So how far
2.
Okay, so
1 point.
x equals 1.39.
I'm so glad we got the same.
It disappeared.
1.3. What? It's like 1, but
It was like, oh.
1.39 circle.
For the people that start their ones from the bottom.
what?
Ugh.
Or like last year, they would be like 9.
Oh,
Who does that?
that doesn't look right.
Or like people who start their P's like right here.
Die.
Yeah.
I'm sorry, that looks like a really.
That's
odd
actually a
test.
symbol in physics that you do write that way. But
Oh.
that's much later in the year.
Is that one of those like Greek letters?
Yeah, it's rho.
0.
What's the 0 for? Is it just
That
like-
is the 0. That's what that question was asking. So I didn't want you to like look back and be like, oh, I solved that and I got 1.39. Like what?
So like I circled the 1.39, but I realized that it looks more like a potato.
What?
See, my circle's the shape of a potato. See,
Oh, a sponge.
it's a potato.
Okay. Oh, this was probably a formula. Did you have a formula like a P of T equals in your notes?
No.
It was just 2 graphs.
Okay. Just checking. I need to give you this formula then when we do this problem. Okay. So these are word problems, sort of, kind of.
Oh, the horrors.
They're exponential models. So population growth. The population of Silver Run in the year 1890. So year
Is this like a
1890.
piece of tea thing?
P of T is equal to P times 1 plus R raised to the T. Yeah.
1890.
So in the year 1890, there were 6,250 people.
What? How many what's?
People.
Okay. 6,250
People.
people.
Assume the population increased at a rate of 2.75% per year. Now, part A. Estimate the population in 1915 and 1940. Now, we are going to call year 1890 year 0. Any idea why?
Because it's
Because it's the first one and it'll make things easier for us.
Yep. So what year does that make 1915?
Year 25.
And what about year 1940?
Go for Virginia.
oh, year 50.
Say it.
Wait, 50. It didn't look right.
I know when you said it, I was like, wait a minute, I need to process.
I know.
It's like, I need to make sure. Okay, so I also need this percent as a decimal, so what would that be?
0.02. Finish this.
75.
It's like any day now. You know what that is? Okay. So the formula that we need is P of T equals P times 1 plus R raised to the T. Anyways, okay. So I'm gonna plug in stuff. So my initial amount at year 0 is 6,250. So that is gonna be P. So we've got 6,250 times 1 plus R is
0.27 or wait, 0.0275.
Yep. I paused because I lost it. And so you started saying it. I was like, thank God. I couldn't figure out where it was.
I was like, oh, she's asking us. And I was behind it.
No, I just couldn't find it. My hand was like in the way, so I couldn't see it. So I was like, where is it? Raised to the T, so we're going to call that 25 for the first one. Y'all can find that.
How far do we round?
Well, I mean, it's people.
It's people, so we need to round to a whole number.
I hope it is right. 1, 2, 3, 1, 4. I mean 5. 12,315.
There we go. So that was in the year 1915. For the year 1940, we set it up the same way. Maybe I won't lose the number this time. Kind of looks like a 9, but it's a 4.
Wait, why is it a 4? It's supposed to be a 5.
50. I was looking at 1940. Hold, please. Literally, I'm just like ignoring everything that like we wrote as like the necessary information and reading everything but that.
Just going our own way.
And then I was like, it looks like a 9.
Okay, so
Depending
that
on how
is-
you input it before, you can probably hit second entry and just type it in.
So that's 24,265.
If it's double the amount of years, how come it's not at a double the number?
What?
It was double the amount of years, so why is it not double the number?
Because it wasn't double the amount a year.
25 to 50, it's double. So why is my answer not double?
Oh, that's what you meant. Oh, because it's exponents.
It's a trick question.
Oh.
Virginia's over there like fully pondering life, and she's like,
I didn't understand what you were
She's
saying
like-
at first.
felt like she was about to be like, no, the answer can't be. That's no way that's
I
right.
was like, no solution.
Let's see. Part B says, when approximately. Actually, it says approximately when did the population reach 50,000?
When God reached 50,000. Okay, so we put 50,000 on the left. That's
Yep.
what the P of T is.
The only difference is, well, the two differences. We have the 50,000 on the left, and our exponent is t because we need to find the number of years. Y'all remember how to solve these?
Well, we have 8 equals like
Yeah.
1.0275 to the T. And then just close around. Oh, this is the L. 'Cause find something interesting?
No, I'm just staring off into the distance while I'm waiting for an answer.
Well, I think we do the L thing.
Yes.
Vlogs. Our favorite.
See, these days are just so long. I'm just zoning out.
No.
So, like, how far out do you want us to go for time?
I would go out to like still 2 decimal places probably.
So we have 76.65 years.
So that's how long it is to get there. So what year is it that we hit that population?
So, like, mid-June of 1966. No, not mid-June.
It's not mid-June, but it is 1966.
So, like, end July.
So there's 12 months in a year, not 10. But yeah, all we need to say is the year.
I promise I'm not stupid. Although I do have my moments.
What time is this class? 39?
Yeah, we have
Okay.
7 minutes.
Okay, let's see if we can power it.
It's not even that long.
I know, I feel like this class went by really
I
fast.
know.
Well, the 5th period class on Thursdays always does go by fast. I think it's the shortest one of the day.
Maybe. I think it's also shorter because, like, I literally didn't get up here till after the bell rang anyways,
Yeah.
and then I had to go deal with the other stuff. So I guess that's why. I don't know. It just seems
Yeah,
that means 6 period's gonna feel really long. Okay, one more question, and then not tomorrow, maybe, I don't know. I might make these copies or try to get these copies made and give these to you during physics so that you have them for reference. Y'all are like siblings.
I know. It's like, one of these days you're actually gonna like kill me.
John invests $2,300 into a savings account with 6% interest, or like a 6% interest rate, compounded annually.
I remember
I don't think I spelled annually right. I did not.
this. Isn't this the one that's like hurt, or am I making that up?
Pert.
Yes. That's for continuously, but I think. I don't know, I mix them up all the time. But this one's compounded annually. I thought you were about to chuck that at me. I was about to be like, not if you want a good grade in this class, you ain't.
Oh, you see, you sure you like
No, I-
yelled and the video just ends. No.
Be like, and class is over. It's like Larry the Cucumber when he's done playing his song at the end and he just collapses on the ground and then it's like toot and then the confetti comes out.
You get little poppers.
Okay, compounded annually. How long will it take until John's account has a balance of $4,150?
Why does it need $4,150?
I don't know.
Is this guy like willing to wait like a while or something?
So basically, we do this problem the same way we did the last one, like the part B of the previous one. So we have 4,150 equals 2,300 times 1 plus 0.06 raised to the t And yada yada yada.
Ew. That was a little aggressive, I'm sorry.
Just a little.
But I don't like the number that it showed me. What number do you have? How far out do you want us to round for thingy?
2.
Do you want us to use a rounded number or the calculator number?
Like when we divide 41.
Oh. I have mine, it looks like rounded to 2 on my paper. It'll might be off by like a little bit when you get your final answer if you do, but I would just do that.
Do we always have to go to the math thing to do the log base?
Yeah.
I got, wait, what are we measuring? How long? I
Time
got
in years.
10.09.
Yep.
So this guy's just gonna sit around waiting like a little over 10 years just to get that much money?
Guess so.
Like, he could just
It's only
like,
getting compounded once a year.
like he could just like,
It's crazy.
oh, so you mean
Because
to say
remember,
that
this would, if it
goes-
was compounded quarterly, it would be like 4 there. Oops.
So does that mean that he would technically have to wait 11 years?
No, he would have to wait 10 years and basically 0.1 months, like 0.1 of a year, so a little over a month.
So like they continually compound it, but like the whole increase per year is 6%.
Yeah, I mean, it doesn't give us enough information to know if,
Yeah.
like,
So
he's
it's
not
not
going to
like-
hit that amount until you're 11 or...
So it's not like, okay, so we're at year 1, like
Yeah.
we're at year 0, so you start out with that much money. It doesn't do anything
until
like
the end of the
first,
year.
Like 364 days.
Right,
But then on day 365, you got some extra money.
right.
And if that were the case, then yeah, this poor guy would have to wait 11 years.
There might be one more problem that I do with y'all on Monday out of this section after we go over the little worksheet thingy that I'm going to give you later, but...
Worksheet thingy. That's a great name.
Let's see. 159.
This was 1.3, right?
Yeah.
5,
21. And
I knew it was
Ow.
5.9.
25.
1.59 is in pi.
2, 6, 5, 3, 5, 8, 9, 7, 9, 3, 2, 3, 8, 4, 6, 2, 6, 2, 3, 3, 2, 7, 9, 5, 0.